Okay, here we go. Direct substitution is the way to go, because if you can get this to work, it's easy. So, what's the limit of this function as x approaches 3? Try it. Do your direct substitution. See what you get. 3 squared minus 9, 3 minus 3. On the bottom you get 0. On the top you get what? 0. Hey guys, if you get 0 over 0, which you will get a lot, by the way, it doesn't mean that there's no limit. It actually means that the limit does what? It does exist. There is a limit. It's a hole in your graph, and that's why you can't put a number in and get the answer out. So, you need to do something algebraically. Okay, so here's what we do. We take our function, take f of x. This is just f of x right here. Take it and do this. Simplify. Okay, you did this back in chapter 2. How do you simplify fractions that are your function? Factor the top, factor the bottom, and cancel. That's what we did. How do you factor the top? Okay, this is the difference of two perfect squares, right? And because it's a difference, it's going to be x plus 3 times x minus 3. Will, you okay over there? No?
Yeah.
All right, stay with me now. All right, on the bottom is x minus 3, right? I can't factor x minus 3. It's just x minus 3. Now, I'm trying to simplify this. Anytime you have multiplication going on top and bottom, you can cancel. So to me, I got my multiplication right there, right here, and I do have multiplication going on right there, 1 times. So I hope you see it. What cancels? X minus 3 with x minus 3. So what's the final function going to look like? X plus 3 over 1. Don't really need the over 1 stuff. Okay, now try to remember what you're doing. You're trying to find the limit as x approaches what? 3. Now stick with direct substitution. Never go away from direct substitution. Put it in. What's the limit?
6.
6. That's the answer. The limit is 6. That's all it is.
So this is what we're basically doing today, just factoring?
No, no. This is one method of, and this will be the easiest method. Factoring is so simple for you guys now. This is easy. Factor, factor, cancel, cancel. Direct substitution, you're done. Now, here's what probably happened, by the way. Because you got 0 over 0, that means there's a hole. Just so you know this is probably what's going on. 1, 2, 3. Come in from the right, come in from the left. There's a hole at 6. Here's my guess. This is just a guess. The function looks something like that. Because remember when you put 3 in right away? Right away you put 3 in. And it has an open circle there. And because it has an open circle, 3 doesn't really get an answer. So that's why you got 0 over 0. And now you have to go mathematically figure it out. Okay? 0 over 0 just means a hole. Next. What's the limit of this one? Where would you start? Oh, I knew that was going to happen. I don't want you to factor yet. Direct substitution, guys. You might get the answer right away. Ready? Put it in. 2 squared minus 4. Up top, it's 2 squared minus 2 times 2 minus 8. On the bottom, I think we're getting a 0, aren't we? What are we getting on top?
Negative 8.
4 minus 4 minus 8, negative 8 over 0. Ah, yeah. This is the one you're hoping for on the test. Any number other than 0 on top of 0 means there's no what? There's no limit. It doesn't exist. What does that mean? What happened on the graph?
There's a hole.
There's what?
A hole.
No, holes are when you get 0 over 0.
Must be like an asymptote.
It's an asymptote, exactly. So when I said as x approaches 2, watch, 1, 2. Here's what happened. Right at 2, there was an asymptote, and it went like this. It went like this. So as you close in on the left and you close in on the right, your answers get nothing but bigger, bigger. As you close in on the left, your answers get nothing but what? Smaller, smaller. You're not even getting close to the same answer. You're going the opposite direction. You're actually getting, the closer you get to 2, what? The further away you're getting with your y values. You're not even coming close to the same number. Okay, this is the one, believe it or not, you are hoping for this on the test. Once you say that over 0, you're like, yes, D&E, I'm done, I'm moving on. This will happen at least once on the test, maybe twice. Okay? Okay. Move on. We don't have to factor. Don't factor. Although if you did factor and you factored it out and canceled it out, guess what would happen?
It's the same answer.
You get negative 8 over 0, and then you can go what? Oh, it doesn't exist. All right, ready? Let's do this one. This is a wicked, wicked looking function. If you do your direct substitution, go ahead and do that. I'll let you get ahead of me. Put 0 in, see what you get. What are you getting on top? Aren't you getting 0? Square root of 1 is 1. 1 minus 1 is 0. Oh, means what? It does exist. I can't tell you what it is, but it does exist. So this one says, yeah, it does exist. We got to go find it now. Okay, so how are we going to go find this one? We got to think algebra. How do I simplify that ugly looking function? Okay, so I need help. I'm going to rewrite it. How could I change the look of this thing?
Square the square root.
Say it again.
Square the square root.
Just the square root? So you're telling me just the square of this?
Yep.
Am I allowed to just kind of pick any term and square it? 3/4. Am I allowed to go, I'll just square the 3 and get 9. 3/4 is the same as 9/4?
So you have to square everything?
I have to square everything to be allowed to do that. But Corey, I got to tell you something. If you did this, you'd have to FOIL this out, and guess what would happen? You'd have even more. You'd have more square roots. You'd have a really ugly function, even more ugly than this. So, Corey, good guess, but not quite what we're looking for. Hey guys, we actually did these problems in chapter 2, but we had our square roots where? On the bottom. Does this ring a bell? Rationalize the denominator? That just meant get the square root off the bottom. Well, I'm telling you to rationalize the what? Numerator. Why would I? That's weird. Why do I have to get rid of the square root on top? I don't know. But I do know. Because when we do it, it's going to give you the limit. How did you get rid of radicals?
You square, you mean from the bottom?
Okay, from the bottom. How'd you get rid of it?
If you had like square root of 2 on the bottom, you would times square root of 2, that would give you like 2.
So you did this, right? Okay, that's right. But I don't have just the square root of a number. I have the square root of a number minus a number. Remember how to do that?
You have to switch this on.
Multiply by what? Square root of x. You said minus 1?
Yeah.
Then what? That's it?
Plus 1.
Plus 1? What do you think? Oh, they're so close. They were so close. Do you guys remember what conjugates are? Conjugates? Multiply by the conjugate. Well, the conjugate was leave the first term alone. Don't touch it. So if you would have just said square root of x plus 1, but the second term, minus 1, change it to plus 1. Now we got it. That's it. You were supposed to multiply by what we call the conjugate. This is back in chapter 2, guys. I know that's a while ago, but that's what you do. So you got to multiply the bottom by the conjugate. Square root of this plus this. Okay. Now, you don't remember this stuff, I can tell. Do you remember when you multiply conjugates, something happens? When you FOIL this out, what happens? The middle terms cancel out. So when you FOIL outer, outer, inner, inner, do you really have to do it? I don't think so. They cancel out. No. So what would I be doing in the word FOIL? First times first, do that one. So do this. And what else do you do? Last times last, do this. And guess what? You'll have the answer in no time. So what is the answer when you take the square root of x plus 1 times itself? Say again.
X plus 1.
X plus 1. There you go. The square root of x plus 1 times the square root of x plus 1 is x plus 1. What's negative 1 times positive 1? Negative 1. Oh, look at the top, guys. X plus 1 minus 1. It's just x, but we'll get there later. Okay, what about this mess down here? I'm going to tell you something right now. I'm going to try to save you time. Do not multiply, because you're going to distribute that through, and then guess what you'll do in the end? You'll factor out the x, and then you'll cancel. Don't do it yet. Just take it, x times what? This plus this. Just leave it alone for now. Now you guys all know that and that are gone, right? So you have x over what? X over x times. So you have a number, x on top, over x times another number. Well, anytime you have a monomial with a monomial, go ahead and get rid of them. Same monomial. And by the way, when you cancel out monomials, you just say 1 over 1. So what's the final answer now? 1 over, yeah. There you go. You took the top, you got the radical off the top, and now it's on the bottom. It seems weird, doesn't it? It's like, did I really make this better? Well, you did make it better. Look. What's the limit as x approaches what? I can't remember.
0.
0. Direct substitution. See if you get something now. 1 over square root of 0 plus 1 plus 1. What? 1/2, isn't it? What's the limit? The limit is 1/2. If you went out and graphed this thing with your graphing calculator, and then you approached 0 from the left and 0 from the right, and you looked up, oh, it's 1/2. The answer's 1/2. Okay? Now guys, don't flip, because there's another one to do, and I wanted you to do this one on your own. So do this other one right here. Right? Come on. Do that one right there. Okay. This is for you to practice on. I just did one now. So what's the limit of that function when x approaches 3? I know you don't want to do this, but I really don't want you to skip this step. Try direct substitution, because if you actually get a number, that is the limit. Ah, shoot. We didn't get a number. We got 0 over 0, which means the limit Does exist. You have to go find it. Now do what we just did on the previous problem. Please don't get too far without looking up here once in a while. What was the conjugate of this on top? Square root of 7 minus x plus 2. Did you write that? Is that what you did? Okay. Keep going, keep going. Well, there's not much to do on top. First, first, last, last. And then the bottom, I kind of told you don't do anything because if you FOIL this out, this is quite a mess. And what we're looking to do is cancel. That's what we're looking to do. So, what's the top?
3 minus x.
Say again?
3 minus x.
Okay, 3 minus x, which is a binomial, right? So you got a binomial over another binomial. This is a binomial. Obviously, 3 minus x, but 3 minus x does what? Cancels. So you get 1 over times that. So here comes the final answer. No, I shouldn't say that. It's not the answer. It's just a simplified function. We still have to do this. Isn't that what we still have to do?
Isn't it always just 1 over the conjugate?
I don't think so. I don't think so. I don't think it's that easy, to be honest. It might have been in this one. What's this? Put that in. 1 over the square root of 4 plus 2, which ends up being what?
1/4.
There's your limit, 1/4. Yes? Okay, this is called rationalize the numerator, not the denominator, the numerator. Just change it up a little bit and see if it works. It did work. It got 1/4.
So it's not just 1 over the conjugate?
Well, Colton asked me that. If you did 4 more of them and you got that every time, maybe you can go with that. I've never looked at it that way. Do a few in your assignment, see what happens. Okay. I honestly don't know. I haven't looked at it that hard. Okay, this one. This is a fraction. This is a fraction. Do you know what it's called when you have fractions on top of fractions? What's the name of this? Complex. This is a complex fraction. Okay, so you're supposed to take this function, evaluate it at 0. So substitute it in. Substitute it in. Do a quick direct substitution here. Well, on the bottom, it's easy, 0. What do you get on top?
6 over 2.
You're saying this one's 6 over 2?
That's 0. Oh, wait.
Isn't this 0 going to make this 3 over 0 minus 2? Isn't that just this? What's negative 3/2 plus 3/2? 0 over 0. That's bad news for you, because that means there is a limit. We're just not getting it. So now we got to do what? What do we got to do? simplify. We have to simplify the complex fraction. I'm going to rewrite this. 3 over x minus 2 plus 3 over 2 over x. Okay. Somebody out there, tell me how to clean the mess up. Well, okay. I do know this. When I have a fraction, if I multiply the top by a number, the same number on the bottom, I get an equivalent fraction. It's the same fraction. So if I just multiply top and bottom by a number, I can make this easier looking. I think I can. I just want you to tell me, what's the number I multiply by? Okay, what makes this thing ugly?
Top.
Okay, what about the top? What makes it ugly?
There's fractions on fractions.
There's fractions on a fraction. But if you look at the top, isn't it the denominators that really made this ugly? So what I'm asking you is, clean it up. Get rid of those denominators. What would you multiply by? X minus 2. He said, this is what Tristan says, just multiply by x minus 2 and it will clean the mess up. I think he's right. If you took that times that, because the x minus 2 would cancel with the x minus 2. The problem is, if you take x plus 2 times this, you're still going to have a fraction. So it's not just x minus 2, guys. It's what else? 2. It's both denominators. You just multiply by both denominators. Okay? But if what you do on the top, you got to do on the bottom. So you might as well just copy it on the bottom. All right. This is where I lost period 4. Period 4, I lost them right here.
X plus 2 or x minus 2?
Oh, it's x minus 2. My fault. Good catch. Okay, Colton caught me. X minus 2x minus 2. Okay? All right. Like I was trying to tell you, I lost period 4 here, right here. So make sure you're with me. This is a fraction. It's 3 over x minus 2. Do you guys realize this is just one number out here? It's just 2 times x minus 2 over 1. So if I actually did this, x minus 2, what happens when you take that fraction times that fraction? Those are out, and you get what? 6. Now, I would not write this on the side of your paper. I would just go like this. I'd just go, hey, x minus 2 with an x minus 2. That's easy. What's left is 2 times 3. That's 6. That's what I would do. When I do the next one, I have to get rid of this little line I put there. Okay, what's x minus 2 times this one? That 2 have canceled out.
3x minus 6.
Yeah, it's positive 3, so it's positive 3x. Take away 6. And you guys should be smiling right now, right? You got a 6 minus 6. You know that's nice. Okay, on the bottom, I wouldn't multiply because you want these to cancel. See that 2 in the back? I would really like it in the front. Is that okay if I do that? So put this 2 in the front. 2 times x minus 2. Okay? Now, I'm almost done. 6 is out with 6. So what I have is this. 3x over 2x times x minus 2. See any canceling going on? X's are out. What's the final function? In simplified form, it's this. But remember, you're trying to do this, aren't you? Figure out the limit as x approaches what?
0.
What?
0.
0. Oh, by the way, that equal sign doesn't belong there. I'm sorry I put it. The equal sign belongs over here. What is the limit of that function when x approaches 0?
-3 over 4.
Yeah. 3 over 2 times -2, negative. There it is. You get it? I know those problems seem long, and they are kind of long. Okay, there's another one right here. I don't know if you can see it or not, but it's there. It's right there. Okay, let's take this one, bring it down. And I lost it already. Okay, keep coming, and there you go. It is the limit of cosecant of x over cotangent of x as x approaches what? Pi. Okay. Direct substitution. Put it in. See what happens. Pi goes in. Pi goes in. Right? Let's see if we get this. What's cosecant of pi over cotangent of pi? And by the way, pi's right there. What's that point? -1's 0. Ah! Is that really it? That is it. How much more did I have left? Oh, good. I was almost done. Let me make it. You guys, you might struggle with those trig problems. There's a couple trig problems like this one was. Look at the example. You might be able to figure it out. We'll start here tomorrow. Right there.
If we get through all the stuff, that'll be on the assignment.
Yeah, except for that one trig problem. And I think it happens 2 times, maybe 3 times.